Okay, so I'm assuming now that you've had a go at these quick questions here to practice the product rule from before. And as you got to these questions here, you would have handled this as cos x and x to the power of -2 if you were using the product rule. The good news is there's a quicker, well, usually quicker, there's what is normally a quicker way by using a different rule. And this rule is the quotient rule. It's when you have the format of some function of x over another function of x. Okay? It needs to be a function of x, though. So, for example, if you see something like this, this is not the quotient rule. Yeah? This is just half x to the -1. You can just differentiate that as you normally would. So be aware of overcomplicating things. Okay? It's when we have things like, well, this is more of a proof here. It's when we have things that look more like this. Okay? Clearly, there's something about x going on at the top and x in the bottom. So here's the rule. If we call the top part u and the bottom part v, then the rule is v multiplied by the derivative of u minus u being multiplied by the derivative of v, a little bit like before, but it's sort of all gone a bit negative now and switched its way around. Finally, everything's being divided by v squared. So let's put this into practice. So if we have u over v, the format is v du minus u dv over v squared. So lay it out just as we did before. U and du, v and dv. U is x, v is 2x plus 5. Differentiate them and have them ready to go before you try to put them in. Now substitute into the formula. V du. Well, 2x plus 5 multiplied by 1 is just 2x plus 5. It has a subtract sign, okay? So everything's kind of backwards, so the order's sort of changed, and instead of positive, it's negative. This is how I like to remember it. Then the other two multiplied together, so it's still about like that pair and the other pair. It still sort of works like that. This is minus 2x, because it's 2 times x. Finally, it's all over v squared. So it's often a good idea to sort of leave it like that and not necessarily expand it out. There's often some sort of cleanup that you can do. And so we have our final answer. Okay, so if you want to differentiate y equals all of this, we get dy dx equals all of this sort of stuff here. Let's do another one. So u equals sine x, v equals e to the 2x, du, dv, du is cos x. There's no number there, so no chain rule. Sine just goes to cos. Here there's a chain rule, so it's 2e, 2 to the x. Now, v du minus u dv, okay? All over what? All over v squared. V squared is like that this time. Notice if you don't actually square it, then you can see something here. So everything seems to have an e to the 2x in it. Perhaps not surprising because e differentiates to e. That's sort of why this is happening. So we get cos of x minus 2 sine of x over e to the 2x. Okay? Find the stationary points. Well, that is when this is equal to 0, because this is dy dx. When will this thing be equal to 0? Well, it's not. We don't divide by 0 or infinity or anything. We don't do anything like that. What we do instead is we look at the numerator. So the numerator should be equal to 0. So cos x minus 2 sine x is equal to 0. What you will do is you'll get 2 sine of x equals cos x. And you might have forgotten because it's been a while, but when you have sine and cos and there's no numbers involved, what you want to do is you want to use tan. So 2 tan x equals 1. If you divide both sides by cos, you'll get this one here. And now you need to solve this one. Did you remember to use radians? Because we've differentiated with trig. So even if it didn't have that there, okay, we would need to make sure that we use our calculator in radians for the last part. So v du minus u dv over v squared. It must be burnt in sort of to your mind, okay? So it's one you have to learn and you have to get fluent with by doing lots and lots of practice. Pause the video and test your understanding of those questions there on the board. So assuming you've done that, u should be sine of 4x, v should be x cubed, and v, well, there must have been some simplification. So v du would give you, and I would never recommend trying to do this in your head, okay? Even after teaching this a bunch of times, I still wouldn't try and do this in my head. But just so you can see, v du would be this one here, minus u dv, so 3x squared. And what did I say? v du minus u, yeah, so my u is missing, sine of 4x, okay, over v squared. Well, x cubed squared gives you x to the 6. You should be on the lookout for opportunities for cancelling. Numbers cannot be cancelled. Cos and sine cannot be cancelled. X's can be cancelled down. So x squared, that will just become an x there, and we get this answer at the top of the board, okay? That's where it comes from. Final mark often comes from cancelling there, okay? So make sure you do that. What have we got over here? So this looks like, what does that look like? E to the x root 3, or sort of like root 3x, okay? So this will be, well, what's this? This is actually a product rule, isn't it? Okay, so it's been mixed up with a product rule. So that would be u and that would be v there. Okay, what's the rule for the product rule? U dv plus v du. That's all you had to do for the product rule. Whereas the quotient rule is like this. Okay. And as you can see, they like to often sort of add extra parts. So when you find a gradient, you might have to do something to do with a straight line or turning points. All of those uses of differentiation are still there as well. Okay, so I recommend lots and lots and lots of practice now with the quotient rule until that rule becomes fluent in your mind. And also, it's a good idea to do some mixed questions where you're not told which rule it is. So you need to get into the habit of moving between the product and the quotient rule. And remember the chain rule. The chain rule is about a function within a function. So chain rule is not separate to any other rule. You may have to do the chain rule at any time. The product and the quotient, however, are quite separate. You have to pick one or the other if the question suits one of those methods.